with Marco Villaneda. And we start this paper when I was visiting Wuhan, and I returned to Brazil. I tried to, first, the main idea of this paper is a situation we have here in Brazil to price interest rate options. And so was motivated by this real problem. And we wrote this paper. When I returned to Brazil, I tried to present this paper for some hedge funds, banks, broker house to show how we solve the problem they face on a daily basis. Well, at that time, the answer, or almost no one received me. Okay, it's interesting, but we don't understand. We prefer to do the way we are doing. And it's not working perfectly, but we are comfortable. But recently, I started to receive many calls and from the industry saying, please, professor, come here to explain your paper. Now I grabbed the attention of the industry, so I resumed this paper. So for instance, here is a report from Itaú Bank, and he explicitly used our paper, our idea. So Mark and I resumed to work in this paper, so we understand the main idea is still practical for applications, but not only in Brazil, where we have this type of overnight options, but for any country who has overnight future or overnight options, okay? So that's the main short story to tell about this paper. So the main idea here is this chart. So here we are talking in a country as Brazil who has an inflation target regime. So we have regular or scheduled meetings when the board of directors from the central bank decide what would be the target of the overnight rate. So the overnight rate here is in red, okay? So we have in these black lines the scheduled meetings. And in blue line, we have the real overnight, the interest rate that banks and financial institutions exchange fund money between them. Okay, so they are very close. They are not the same, but they are very close. What we observe is the interest rate, the overnight interest rate, change when we have the expect meeting from the board of directors. When they decide, okay, we will increase or we will decrease the target rate, so we see automatically the effect on the overnight interest rate. So what is basically new in this approach? We could use, for instance, a jump diffusion process. In this case, we would simulate the jumps, like here with stars. And in this simulation, we would have the intensity decreasing or increasing on average what we expect as a result of the board of directors. The problem is, in this case, I run 1,000 simulations and I calculate the frequency of where the diffusion process with jump had a jump. For instance, I had one here, 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 but no jump happened the exactly day that we had the scheduled meetings. So in other words, if I would use a pure jump diffusion where both dimensions are stochastic, the time when the jump happened and the size of the jump, I wouldn't price correctly any derivatives. So the idea is, okay, I know when the meeting will happen. What I need to estimate is the size. So if I compare with any jump diffusion process, I will have this misprice when I ignore the fact that I know exactly when the meeting will occur, but I don't know the size of the jump. Okay, so that's the main motivation. So as I said, this structure might be applied for any country using inflation targeting, or as in the United States, the United States doesn't have declared inflation target regime, but has very well-known meetings run by the Fed. So we could borrow this structure for pricing overnight options and futures. So the stochastic time jump or the pure jump diffusion ignore the fact that we know when some event will happen. And more important, if we want to price correctly both instruments, futures and options, I need to have a way to bring the information from futures, which are usually more liquid instruments, to price options. So the idea is to make both pricing problems compare consistently. That's the main idea. So pricing interest rate futures, which are very liquid in Brazil and in different countries, and options, which usually are less liquid than future, we want to price both in a consistent way. So it's a standard option future price or a bond price. If I want to calculate a zero coupon bond, I will calculate the expected value of the integral of the short-term rate condition on the information using a Q measure. So with or without jump, I am able to solve this problem, use Laplace transform. But as I said, if I ignore the fact that I have a meeting between small t and capital T, I will misprice the bonds or future or the options. So as an ad hoc way to work around this construction, okay, let's assume that I know the date that the meeting will happen, I know exactly, but let's assume that I know how much or the size of the decisions. So he will increase or decrease the interest rate by the parameter theta. So I can correct the bond as I'm showing, but let's assume even more that we know that the interest rate from today until the moment that we have the meeting will be stable. There is no reason to suppose that the central bank will call for extra meeting between the schedule one. So that would be ad hoc way to incorporate interest rate and the schedule meetings. Why I'm bringing this? Because most of the traders in Brazil use a structure like this. They use the expectation they have, what they are assuming based on the economic reports released by the economics department, and they exogenously correct the price of the bonds or the future using what they have as a spot rate, and then calculate the bond price or the futures. What I'm trying to explain is as in this figure. So here is the overnight interest rate in Brazil. Here is the maturity of this future contract or a bond. So I have 15 days before the meeting. So coupon is the equivalent of the FONC meeting, but in Brazil is the board of directors who decide what is the target rate. So I have the meeting right here, and I have 5 more days until the maturity of the contract. So what I'm saying is basically I'm compounding 15 days with the standard rate, the overnight rate, and the remaining 5 days I will decrease my expectation 50 basis points from the overnight rate. So I would have like a 10% rate. That's the way in general trades does in Brazil. Okay. How can we incorporate more structure and avoiding this fact that, okay, I am assuming that I know what will be the central bank outcome. So the problem is, as I said, both rates or both components are stochastic. The overnight rate is stochastic, and I don't know what will be the decision from the central bank. Okay, so again, as I said, we could use jump diffusion to simulate this process. In fact, Levy processes are good for fitting. So if I want to only fit my options price, I will have a good fit with using any jump diffusion. But traders want to have, or traders want to incorporate their expectation about the potential result of the central bank. So we are assuming that the central bank will cut 50%. So I need somehow to incorporate this information in the pricing and not having this outcome given by the model. So that's the main idea. So if we assume right now diffusion process with the examples I will present a specific diffusion, but right now I'm just using a given diffusion process with a given drift and a given diffusion. So what all the construction will be, I have an overnight interest rate and I have the result of the central bank. So I'm trying to somehow use the exogenous constructions made by traders in a formal model. So what I'm saying, between two meetings, I have the overnight dynamic as described by this diffusion, and as I have a given day where the meeting will happen, I have this variable capturing the result of the central bank meeting. So if I use this capital R as the result of the overnight rate plus the result of the central bank decision and the previous formula for pricing bonds, I would have a construction like this. However, this might be too restrictive for describing the option price, but I will present some evidence that we are not being too conservative. So, as I said, here is the dynamic, again, the overnight rate, and here exactly happens the jump. So we don't have jumps occurring between two meetings, between two scheduled meetings. So as I said, we have fluctuation here. This model will be given by the diffusion part. And here, as we have the scheduled meeting, I have the result, and I don't know the outcome from the central bank. What we're going to do is using market information, trading from liquid instruments like future to price less liquid instruments such as options. So to solve the problem, what we need to impose is the overnight rate and the target rate are independent. And here we have the overnight rate, and here we have the monetary decision. So we don't see any specific behavior or clear behavior between these two variables, and they are two, as a linear measure of dependency is very low, so we can follow with this approach. But however, even if R, capital small r, and theta are independent, I want to introduce some dependency and theta. Theta will be the results or the sequence of actions taken by the central bank. So if we are in a losing cycle for the monetary policy, I want to include that. So the central bank follow, in particular in inflation target regime, he follow a strategy. Okay, I need to bring the inflation close to the target. So I will increase or decrease the target rate to bring or to decrease the gap between the observed of inflation and the level set by the government. So we want to have some dependency on theta. And the way we do that is including a Markov chain structure. And in this structure, we'll capture basically these monetary cycles, or the central bank start to decrease interest rate or increase interest rate, not randomly, but according to a given structure. So one way to show just to present the idea, I won't use the tau coefficient for measure anything, but just presenting what we have here is the outcome of the central bank in one given moment and one moment before. So what we see is we have a kind of dependency as we expected in this quarter. What we see is this structure. So if I have less meeting increase, the probability of having another increase in this meeting is higher than increase and decrease. And this information we will extract from liquid instruments like futures. So, okay, here just to say that even though we are talking of using correlation, that's the main is not important for the model itself. And we will include dependency in this parameter by assuming that the decisions from the central bank is driven by a discrete time Markov chain. So once we have that, we will be able to calculate the model. So assuming for a moment that we know the outcome from the central bank, again, and they are independent, so here what I'm saying is if these two processes that I presented before are independent, I can take as independent and solve the expected value very easily. So I will have, again, is a fine solution for this type of problem. Once I define what is the diffusion I'm working with, I will have exactly what are the parameters A and B, right? So for pricing instruments, what I have, okay, I need to integrate all the possible outcomes from the central bank. So if you see here is somehow close to the exogenous construction that traders do in the market. But here, again, I will include some results, and won't be totally exogenous, but I will have the pricing formula. Okay? So as I said, this component, this integral, is the outcome from the sequence of decisions made by the central bank. Okay? So as I said, we are assuming so far that we know the outcome from the sequence of the central bank meetings. But later we will put a more realistic model where we don't know what is the outcomes, but we need to estimate from the market and then price the options based on this information. Okay? Basically, it's a way to extract the implied probability from one liquid market and use to price illiquid instruments such as options. So, as I said, we assume that the decisions made by the central bank will be driven by the Markov, discrete time Markov chain. And what I need to impose is not so, the conditions are not so strict. I need to assume that this process is ergodic, and I just need to assume that is not a periodic chain, and is reasonable to assume that the central bank doesn't have a periodic cycle to increase and decrease, increase and decreasing, so it is reasonable to assume that the decision made by the central bank are periodic. And also, I need to have a finite number of potential outcomes from the central bank. So I will limit the outcomes, and I will show typically the central bank cut or increase quarter of a basis point. So 25 basis point, 50 basis point, 100 basis point, either side, both sides, increasing and decreasing. So I will have a discrete time ergodic Markov chain. Okay, as I am assuming that this is a discrete time Markov chain, I can calculate the marginal distribution for a given state. So using Chapman-Kolmogorov equations, I will be able to calculate the evolution of the probabilities. So if I have, for instance, I want to extract potential decisions from today until 1 year ahead, I will have, for instance, 10 meetings. So I will be able, using this structure, to calculate all the 10 decisions, and they are all correlated because they are assuming they are given by a Markov chain structure. So they are not independent. Once I have the result of the last meeting, I can use this information using Chapman-Kolmogorov equation to calculate what would be the probability of having an increasing or a decreasing by the central bank. And using this information, I will be able to calculate option prices. So these equations simplify when I have only one meeting and I have I know what happened in the past, so I'm predicting what will be the outcome in the next meeting. So that's a simplification useful for calibrating the model. So now bringing some more detailed elements. So let's assume that the interest rate is driven by a Vasicek process. So I'm specifying what is the drift and what is the diffusion coefficient. So and using, again, this is one example, but you could use any other for describing the overnight interest rate. So again, so the observed interest rate will be the combination of the observable overnight rate and the outcome from the central bank, which is a time jump process. So, and again, the evolution of this process will be given by a discrete time Markov chain. So, we know that if the price, if the interest rate is given by a Vasicek process, the integral of this process has a normal distribution. The integral of overnight interest rate is given by is a normal distribution, and the mean and the variance is given by these two terms. Is just to use in our next result. So, as I said, as the price, I can disentangle the overnight interest rate and the outcome from the central bank. I will be able to calculate this expectation separately and obtain the results. Okay, the problem is to calculate this expected value would be not so simple because this distribution would be this one. The overnight interest rate is Gaussian, but this one is a discrete distribution. So this mixture of a continuous and a discrete variables would be not so simple to solve the problem. Our approach was to conditioning, again, in potential values for the central bank decision, and once we condition in all the potential values, we take the average and we solve the problem. So the idea, as I said, if I condition and the value that we know, assuming, okay, all potential values for the central bank decision are given, I can solve the problem as a mixture or an average of the integral, the value that I'm assuming, the values, the parameters A and B from the Vasicek model, and the probability given the chance of happening this decision. And the parameters A and B are from the Vasicek model. So price, interest, futures or bonds would be nothing more than an average when I calculate average, taking consideration the expectation for the potential outcomes from the central bank. So the solution, as I said, is just to use conditioning, as this space is independent, and I have the overnight interest rate and the decision from the central bank. As I said, they are independent. I will conditioning in one variable and solving in terms of another variable, and take all possible values. So this conditional expectation would be very simple to solve the problem, and I will have the result that we want. If you compare, basically what we have here is a time-dependent drift. This expression here is basically similar. This one is basically when you are in whole-white pricing problems is a time-dependent drift that we have, but here we will capture the potential or the expected outcome from the central bank. And here I will give probabilities for each expected value that we want. As I said again, the market will trade this instrument having these expectation and these probabilities. we will need to extract this value, the outcome from the liquid instrument and the correspondent probability, and use this information to price options, which are less liquid than futures. So both instruments are consistent. Futures, which are very liquid, and options, which are not liquid. Okay, so jumping to the pricing itself. So if I want to price, in our case, overnight options, which is basically compared to Asian options, I will need the trajectory of the interest rate from today until the maturity, and I will apply exactly the same structure that I used before. I will conditioning in what I expect will be the interest rate from today until the maturity, and extract this information from the futures, which are liquid, and use this information to price the options. So here's basically explaining the price of this type of options traded here in Brazil. So here, as I said, is the integral of the overnight interest rate, and I will need to include as here the integral or the sum of all decisions made by the central bank. Okay, so here and the way to solve this is basically, again, conditioning on the potential outcome from the central bank for different decisions and taking the mean, the average. So here, as I said, so it's basically an average of Black-Scholes model, or where the weight will be given by the probability of observing that decision. So I assume that I extract from a liquid instrument this value, I plug in this formula, and I will have the price of the options. And as I have not 100%, as I have uncertainty what would be the decision by the central bank, I can split. I believe, or as me as a trader, I believe the central bank can cut the interest rate in 25 basis points with 50% chance, and keep the interest rate unchanged with 50%. So I will take an average of these two results, and I will have the option price. So jump to the one important part is how to extract these probabilities embedded in liquid instruments. So here, this part I present how to do that. But I want to present, here's just some results to present the quality of these algorithm to extract probabilities. What we see basically, jumping. So here's the Markov chain bed in this problem that I estimate. So here I have UDN is up, down, neutral. So he will increase the next decision will increase the target rate, keeps the same, or reduce or keep the same. Okay, here. So that's the Markov chain bed in the problem. So I can simulate all the trajectory for the central bank outcomes. So here, as I show here, I had the implied probability from this simulation exercise. What I have here is the meeting. It was scheduled for 7 March 2012. I was basically one month before, so I have two meetings. So the first meeting, the exercise for pricing exactly is as we were in January 2012. We will compare the model after we have the second meeting in February, and we will compare the pure Vasicek, the Vasicek with this our model with the time jump, and Vasicek, a naive structure using only the overnight as the trader does. So what we see here is here's the maturity here when we have the central bank meeting, and here we have all models. So the overnight is here, the green is the model with the time-dependent jump, and in purple we have the pure Vasicek model. So we now I will show the outcome. So here what we have is the mean square error when I compare the overnight, the naive model, the velocity check time jump and the pure velocity check for pricing futures. So I will use this information to price options. So I will have 2 meetings. I will calculate for a given meeting, and I will show the results. So here I have different strikes. I have the log price. So the cycle is the market, what was exactly traded for these options. This star is the model we are proposing, and the triangle is the pure velocity check. So we reduce significantly the pricing error when we incorporate the information, again, from a liquid instrument, from the market, to price a less liquid instrument, which is the options. So for a given day, for 4th of January, I will calculate for a different day, so for 9th of January, so on and so forth. And consistently, the performance of the model with this correction is better than only a pure velocity check model. Okay? So that was briefly the idea of the paper. So the main idea is to extract information in a systematic way from a liquid instrument and price a less liquid instrument using a consistent framework with non-arbitrage construction, not correcting exogenously as I showed you before. So as I said, now they are using this model actively in Brazil, and Mark and I, we are now working for update the price and more data and have this paper published. So I think I finished in time. Thank you very much.